Hello, and welcome back to lesson 2.4. We're going to talk about the graphs of functions. So I mentioned in 2.3 that there were four ways to tell if an equation was a function. And the fourth way is using a graph. So just a reminder that the domain are all of the allowable inputs. We usually use X to denote those. The range is the values of all the outputs of the function, and we usually use Y to denote those. So to use a graph to decide if an equation is a function, we call it the vertical line test. If you were to draw infinitely many vertical lines through the graph, and each line only crosses the graph one time, then we can say the graph is a function. In this lesson, we also want to kind of reiterate what an x-intercept is and what a y-intercept is. The x-intercept is where the graph crosses the x-axis, so it's an x value when y equals 0, and the y-intercept is where it crosses the y-axis, so x is 0 and at this y value. So I have my first three examples are three different equations or functions, and we're looking to see what their domain and their range are. So I went to Desmos to put them in. And so you can see the link is in Canvas if you'd also like to see the link of the Desmos that I put in, but I encourage you to type these equations into Desmos on your own so that I know you know how to put them in. So when you go to Desmos, remember you can start typing just y equals, Desmos only takes x's and y's as the input and output. So you can turn on and off graphs over here on the left-hand side. You can see where my mouse is on the left. I'm going to turn these graphs off, so I'm only seeing the first one. This is called a parabola. A parabola always has a 2 as the exponent, the highest exponent. And for the domain, it looks like I can zoom in and out over here on the top right. So I can zoom out and see that it looks like I don't have any restrictions. There should not be any restrictions on a parabola or what we call a quadratic equation. And so that means it looks like all of the inputs are going to be all real numbers, anything from negative infinity to infinity. And the outputs are, it looks like everything greater than this number right here, which would be this y value. It looks like it's at a -2, the lowest value. I'm going to zoom in again. So the lowest value it could get is a -2. So let's go and write that on our paper. You're going to use the graph for these. So the domain is a negative infinity to infinity. And it looks like the range, the smallest is going to be 0. And I'm going to put a bracket on that because it can equal 0. I'm sorry, it was -2. -2. And it will go up to a positive infinity. So a bracket on the -2 up to a positive infinity. So let's look at the example number 2 in Desmos. I'm going to turn off the first graph and turn on the second graph. So the square root, you can see that the function of the square root will only have positive values allowed. Whereas you could say the square root of 4 could be a +2 or a -2 as far as real numbers, but as far as the function goes, it only allows the positive. So that's why you just see this right here. So it looks like if you click on the smallest value, it looks like x is this 0 is the smallest x could be. And it can equal that because the circle's closed in. So we're going to put a bracket around 0 and it can go up to a positive infinity. And it looks like as far as y, 1 is the smallest value, and then it continues to slowly increase, but 1 is the smallest value on the range. I'm going to show you my paper here. So the domain is 0 to infinity, and the range is 1 to infinity. And these both get brackets because they can equal 0 and 1. Let's look at the graph of example 3 here. I'm going to turn off the graph on example 2, and I'm going to turn on the graph of example 3. So example 3 goes in the opposite direction, and that's because a -3 is going to be multiplied. So you'd want to put inputs of a negative so that you have a negative times a negative will make it a square root of a positive value is the ideal. And so I'm going to click on the smallest value here, and it looks like it's at 0, 0. So my x's, my domain is going to be anything greater than up to 0. I'm sorry, less than up to 0. And it looks like my y's are going to be at 0 and only go positive because they go up, they increase. So these are going to look different. This time my domain is going to be a negative infinity up to 0 with a bracket, and my range is going to be a bracket of 0 up to a positive infinity. Remember, the infinities always get a parenthesis and not a bracket. Okay. Example 4 says, determine whether the graph depicts the graph of a function or not, and explain your answer. So we said the vertical line test was if I can find even one instance where I can draw a line and it goes through 2 points, it's not a function. Okay. Now we look at B. So B, I'm looking to see, and it looks like every time I draw a vertical line, it only goes through 1 point. So it is a function. Letter C, we just have to find one instance where it violates, and it violates here. It actually goes through 3 points, so it's definitely not a function. Okay. Let's look here at example 5. It says use Desmos to graph the following functions. You may have to adjust window to see them complete. So let's just graph them so we can get some practice in Desmos. This one is an absolute value bar, and this one is the square root. So I'm going to turn that off. And I'm going to type in y equals, it's a negative. Now you can either go down here in the menu, it might be opened or closed. It's on the bottom left, it says show keypad, and you can click on this absolute value bar. And I'm going to put 1.4x. And I'm going to hit the absolute value bar. And then I have a negative 15.2. So remember the absolute value, my picture's over here, an absolute value means that anything that goes in, it will evaluate the expression, and then the output is always a positive of that, because absolute value is just the distance from 0. It doesn't care if it's negative or positive direction. Let's look at the other one. It's y equals, and this one was 1.6, and then the square root of, so that's in our menu down below as well. And then there's that function. Just getting practice with the graph. Reach out if you have any troubles graphing. Example 6 says, for the following function, find these values. So we're getting practice reading function notation, which says f evaluated at a -1. So if I were to put a -1 in for x, so this means x equals a -1. I'm going to go over to a -1, and it looks like my output is 0. So f of a -1 equals 0. Then B says f of 0. So that means that x equals 0. So f of 0, if I put 0 in for x and I go down, it looks like I'm not quite at a -5. So we'll say it's maybe a -4. We're just estimating. Then it looks like the domain for F. So I'm going to go by only what I see here. We're going to assume that this is going to go on forever. Okay. They don't have arrows, but we're going to assume. So it looks like I have no restrictions. I can put any X in. So my domain is going to be a negative infinity to infinity. And then it's asking me for the X and Y intercepts. So the X intercepts, where I cross the x-axis. So let's just see. It looks like I cross it twice. It looks like we cross once here at -1, 0, and once here at 2, 0. So it looks like we have two of those. So we have a -1 and 0, and then 2 and 0. And then the y-intercept, it looks like we just have that 1, and it looks like it's at that -4. We talked about that just a moment ago. So that's just at when x is 0 and then -4. And our last example for this lesson is example 8. It says the time it takes for a person to row a boat 50 miles is given by this function, where s is the speed at which the boat is rowed. So here's your speed. For what values of s does this function make sense? Sketch the graph of the function t using these values of s. Answer: only value greater than 0 can be the domain. The faster you row, the less time it will take to row the boat 50 miles. So you can't have a negative speed. So speed has to be greater than 0. So that means the domain is going to be 0. Actually, we're going to use a parenthesis because it can't equal 0, right? Or we would have an undefined function. So it's going to be an open parentheses to a positive infinity. So catch me back for another lesson. Have a great day.